Hello and welcome. This is a new episode from Aero Arduino, and in this episode, I'm showing to you this video about how to use the LCD with Arduino. If you didn't yet subscribe, please subscribe to our channel to get the latest videos. Many of our friends have asked how to connect LCD to Arduino just as a beginner, and here this video is your guide as a beginner to connect LCD display to Arduino without any problems. And here is the Tinkercad simulation software where you can connect the LCD to Arduino just like in the real circuit. So let's begin with the connection and see the code. Here we start by connecting the 16 by 2 LCD to Arduino using 4 pins of data to Arduino. Here we see in detail how to connect the LCD to Arduino. First, we bring the LCD model from Tinkercad hardware components library. Here are two kinds of LCDs. One is the LCD 16 by 2 that has 8 pins. This one is the one we are using here. And there are another one is called I2C protocol. This one we will see in another video. So we need this one. Click and then drag to bring it to our workshop. And then we bring Arduino Uno module and then connect it to the LCD. As we see here, we connect 4 pins of data. Only we use those 4 pins. DB4 connected to Arduino pin number 6. Of course, you can choose whatever pins you choose in Arduino. And DB5 connected to pin number 5. DB6 connected to pin number 6. DB7 connected to Arduino pin number 3. We just deleted it to see how to connect the pin. Here, first we hover over the Arduino pin like this. Then we click and that we have that wire. And then we click on each point to make a point, a break point. And then we hover over the pin that we want to connect. Then click like this. And on these points, we can move the wire as we want to rewire and to reroute it the way we want it to be organized. If you want to make it like this. Anyway, that's it. 4 pins of data connected to 4 pins to Arduino, DB4 to DB7, and from Arduino pin number 6 to Arduino pin number 3. And then we go to the control pins of the LCD. The enable pin connected to pin number 11, and then the register select connected to pin number 12. Here are the read write connected to the ground, and the V node or contrast. Here we don't use a potentiometer, so we can control the contrast using a fixed resistor, 1 kilo ohm resistor. we can bring the resistor right from here and then click it as we have seen, and then click on the resistor to choose its value like this from the drop down menu, and we print the value we want. Here is a 1 kilo ohm resistor. We connect the contrast pin to the 1 kilo ohm resistor and then to the ground pin. In this way, the V node or contrast connected to the ground through a 1 kilo ohm resistor, and the read write is also connected to the ground. Now we connect the VCC, of course, to Arduino 5 volts, and the ground of the LCD connected to the ground of Arduino board. Now there's something important in the real circuits. In the real world, you can note that thing about the backlight LED. Here the LED cathode and the LED anode. That backlight you see that makes the LCD more brighter, and the writings and the characters on the LCD is more bright, and it looks very beautiful when you use that backlight LED. Here we use that backlight LED using the LED cathode connected to the ground and the LED anode connected to the VCC. Of course, there must be a 1 kilo ohm resistor because it's only an LED. So if you don't use that resistor, you might destroy the backlight LED of that LCD. So we use also a 1 kilo ohm resistor. That was the connection for the LCD to Arduino Uno using 4 pins of data and those control pins and the backlight LED. Now we see the code. It's very simple, and we are explaining it in details. First, we start by including the liquid crystal library using the hash include liquid crystal.h, and then we define the LCD connection points using that line of code. Const integer rs equals 12, enable equals 11, and so on. All these the pins that we have made in our connection. We can choose whatever pins we want, and you can change them right here in that line of code. And then we define the LCD crystal LCD, and then we write down all those pins right here. Each variable or each constant from these constants represent the number that the pin is connected to Arduino. And then in the setup function, we start by initializing the LCD using the function LCD begin and initializing the 16 by 2 because we use that LCD 16 by 2 number of columns and rows. And then here we start by printing our desired message using the function lcd.print hello world, and it prints the text on the LCD. Here by default the message starts from the cursor 0 and 0, and that it's the higher row in that LCD. And then in the loop function, we can also change that message. And here we can leave that message as it is and then start in another cursor position using the function LCD set cursor. In the loop function, we use that function LCD set cursor 0 and 1. 0, that's the first column of the LCD, and then 1, that's the second row of the LCD. And then here in the LCD, we use also the function print to print the number of seconds. So we are incrementing the seconds. That function brings the seconds in milliseconds. Then we divide it by 1000, so we get the number of seconds. Now let's see the simulation, and we can change that code a little bit to see the feedback. Here we start by pressing start simulation. Here we see that the code has started from the point of the cursor of the column 0 and the row 0, that's the row 0 that printed hello world, just as we've seen, like this by default in the message that we used in the setup function. And then here in the loop function, we see that the number of seconds is displaying in the second row because we have written that line of code set cursor 0 and 1. That's the column 0 and that's the row number 1. As we can see here, we can change some things in the code and in the circuit connection, so we see the feedback. First, we can delete that backlight LED so we can see how it looks like without that backlight. You see that it's more dimmer because there is no backlight LED. Then we can change it a little bit. We choose the red color, and then we can make that resistor smaller so it might look brighter. Oh no, you can see here that it was damaged due to the small, very small resistor, and then the higher the current, so we can make it 0.5 kilo ohm. You see it's a little bit brighter. And also this one, this resistor, we can see we can make it smaller like this. I guess it didn't change anything. We can make it like this. I guess it differs in the real world, and this contrast resistor, if you choose to work with a potentiometer, then you can see the difference. But here, even in the real circuits, I use that 1 kilo ohm resistor. Now we can see the code. We can change that code so we can set the cursor on some different point like this. For example, the fifth column, or in here in this case, the sixth column, then we can start. As you can see here, that's the sixth column. 1, 2, 3, 4, 5, 6. That's the sixth column, just as we made number 5 right here, and that it's working. We can also write some code, another message right here using the lcd.print, and then we can write seconds and use that. We can use that to write the seconds, and then we start by placing the cursor to 0 again, and then we can start simulation. As you can see here, the seconds 0 and the seconds are incrementing just as we expected. I'll leave the link to Tinkercad model in the video description. That was the circuit for connecting the LCD display to Arduino as a complete beginner to make your different projects on Tinkercad simulation software. So if you like this video, please click like, share, and subscribe. Thank you and goodbye.